Our next session is Good AI Gone Bad, a zero trust story. Our speaker is the Director of System Engineering in the Middle East and Africa of Illumio. Ladies and gentlemen, put your hands together. Loud round of applause for Michael Adjei.
Hi, everyone. My name is Michael Adjei. I'm the Director of Systems Engineering for Europe, Middle East, and Africa at Illumio. And today I want to talk to you about AI. We've been hearing a lot about AI, and I'm sure you'll hear a lot more going forward at this conference. But I wanted to take a step back and tell you a story about some of the work we've been doing across Europe, Middle East, and Africa, and taking a bit of those stories and putting it together so we can look at, as we've been hearing for our panelists, how good AI can ultimately turn bad and what we can do about it before that happens. So what we'll look at today is we'll look at how AI is being used today, just a brief perception of what people think of AI. We'll then look at the risks associated with AI in terms of the use of it, as well as the development of it. And then we'll look at how we can best address those risks. So first of all, let's look at our world today and what we think of AI. So there are those people that think that machine and man are going to live in harmony, right? There's nothing to worry about. It's all good. Let's all carry on and develop at pace, which is fine. But there are also those who think that everything is going to go to the pot and everything's going bad. AI is going to take over. The machines are going to take over. And we should be very, very scared. The problem is somewhere in between is the key. Because AI, as we know, is used in energy today. AI is used in manufacturing. AI is used in banking. AI is used in healthcare. AI is used everywhere, including on our personal devices. So looking at some of the work that's been done across multiple governments, organizations, and businesses, we're using AI in terms of in healthcare, we're using it in imaging, we're using it in business analytics, we're using it in defense, in law, in education. And this presents to us a very, very interesting conundrum because AI is being used across all of these fields. But one of the things that's actually lacking is we're not necessarily regulating or thinking about the protection of AI at the same speed as the AI is being developed. So let's look at some of the risks that this fast-paced development of AI could potentially present. So first of all, let's look at an organization that has different parts, different offices, different locations, different systems. There's usually interconnectivity between such an organization. And this particular story is an example of one of our prospects or customers that we dealt with that has different locations. It's got different systems that are being used. These are connected over the internet, over private networks, and these things talk to each other. The problem we have is whether we have AI or no AI, we still have the age-old problem of interconnectivity of systems. And that interconnectivity means that if something bad happens, a hacker or a threat gets into one part of that system, it can actually move across. And this is the concept of lateral movement. And over here, we've got some live reporting of stories that have happened across different threats, different cybersecurity events of the use of lateral movement. Some small attack happening somewhere and then spreading across pretty much the globe because all these machines are interconnected. Now, the issue we have now is that AI is going to amplify this risk that already exists. So the risk of something spreading, the risk of lateral movement, is something that's already there. Now we've added the amplification of AI, which means that the threats, the cyber risks, the malware, that's going to be developed even faster. So as governments, as leaders, as cybersecurity people, we also have to think and act faster to try and catch up. So these risks, as an example here, this is a new story about, we just heard from our panel as well, development of AI. And in this case, the AI that was actually being developed ended up learning a new language without the developers actually understanding how it did that. So we have this tool that is actually able to learn, but also potentially able to teach itself things, and we don't necessarily know how it's doing that. And that obviously presents a threat and a risk. We also have research that was done not long ago this year that showed that using the latest ChatGPT, it can actually look out for vulnerabilities using public data on the internet about vulnerabilities on systems, on networks, and computers, and potentially, by itself, develop attacks for those vulnerabilities. So without any hacker, without any human, without anybody actually intervening, you have the prospect of an AI that's able to actually read what's going on, learn, and potentially attack networks by itself. So again, that poses a very, very interesting risk, because now it's not about just the bad guys, it's about the AI itself teaching itself to be bad. And again, this is where the concept of ethics and training comes in, as our panel talked about. So what is the solution here? Should we just do more AI because we have real-time capability? So in this example here, you could have protections like an EDR, right? And an attack, the AI tries an attack, it doesn't work, it's stopped. It updates its code on the fly because it's computer code as well, tries again, it's stopped again, learns more about how the EDR stopped it, and then updates its code in real time, and then the third try, it's able to actually get in. So this is some of the threats we're talking about. Real-time learning, real-time updates, and real-time use of AI in a world where we don't necessarily understand all the intricacies of the AI that we're actually using. So what is the answer? Should we also then do more AI? So we have good versus bad AI fighting each other? Well, yes, but most importantly, we also need to make sure that we get the fundamentals right. I know we're thinking up there, but we also need to think on the foundations of our networks, the foundations of our training, the foundations of the people who we actually tasked to defend these networks and these corporate environments. So we need to reduce the learning surface of AI, the amount of time that the AI has to actually learn things about our network, and the amount of exposure that we have of those networks to the outside world. We need to control access for people who have access to those networks. Not everybody who has access needs all the access. So again, the fundamentals of controlling what people have and what they do when they get that access is also very important. And we also need to be able to contain an attack. An attack will obviously happen. A cyber attack happens pretty much on a daily basis these days. But usually it starts from a small attack on a corner of a network or on someone's laptop or phone and then spreads. So we also need to be able to learn how to protect our networks and carve out those networks so that we contain any spread or potential spread of a bad actor. And of course, we need to have policies in place, systems in place to be able to recover quickly when something happens. Because obviously, we will not be able to protect everything. Something will get through, so we need to be able to contain that thing and then recover quickly from that part of the network before it spreads and becomes a big problem altogether. So one of the answers I propose in terms of this is the concept of zero trust. You probably would have heard about this, and we'll talk about that in a bit more detail. So what is zero trust? It's basically a strategy of least privilege across different spheres of your network, of your daily life. So I like to use this wheel to actually explain what zero trust is. If you think about any organization, for us here, out in the world, across the world, in businesses, in healthcare, in private businesses, and private education, and personal, it's all about people. So you've got people, and you can see that people there in the top left, and those people have devices. They've got mobile phones, they have laptops, they have iPads and all these other things. And they use that to connect over networks. And that's why you can see the networks there. So you have these people who use their devices, and they connect those devices over the internet, over their Wi-Fi, over public Wi-Fi in a place like this, or corporate Wi-Fi. But why are they using this to connect? Because they want to access certain workloads. A workload is basically the server that hosts the information you need. So if you go onto Facebook, you're using your phone to connect to Facebook's workload and retrieve your friends list or whatever you have. If you're connecting to your email, you're using your laptop to connecting into that workload to retrieve those email messages. And that's why data is in the middle, because ultimately, the reason why your people are going to use their devices to connect over networks into those workloads is because there's some data on the workload that they need, either for business, for pleasure, for entertainment, and they need to retrieve that data. So ultimately, it all comes down to the data that is in the middle. All of those things and all those people want to access that data. But how do we actually protect that data? We've been trying to protect this for as long as we can all remember in cybersecurity. But some of the key things is what you can see at the top there, automation and orchestration. You need to be able to automate some of the information. And this is where AI can be quite helpful. Because if you're doing this manually, it's very, very difficult, especially if you're running an organization of 10,000 people, 20,000 people, or if you're running a country of millions of people. It's very difficult to use manual ways to actually protect. So you need that orchestration and automation to help you automate the access that you're doing. At the bottom as well, you've got visibility analytics. You can't protect what you can't see. So you need to be able to see into those networks. You need to be able to understand how those networks are being used, who's coming in and going out, and use that information to then feed into that overall orchestration. So why is this important? Because the bad guys will always find a way in. Before AI, they were finding a way in. Now with AI, it makes it even easier for them to find a way in. And because the bad guys will always find a way in to your network, you also need to be able to have a containment strategy. Not to try and prevent everything, but to try and contain anything that eventually gets in. So containment is the new prevention paradigm, which means that you're not worrying about stopping everything, but you're worrying about how do I detect quickly and then contain it so that it doesn't become a big problem. So 3 key things that you need to have in able to do this. You need to be able to identify any assets that you have, laptops, desktops, mobile devices that people are using, digital assets, AI assets, and all of that. You need to be able to map out and visualize the communication of those things, and that's the risk bit. And you need also to be able to contain those risks by putting in place proactive policies so that when something happens, even if there's no human looking at it, you can automatically have policies in place to contain and prevent that from spreading. So in terms of that, let's look at an example of one of our prospects on how to actually do this. So you have all these assets that are scattered across different locations. They could be even across different geographies and different countries. These assets are doing different things. The first thing you want to do is you want to be able to label them and understand what those assets are. And this is all based on metadata and based on using what we call tags. So you don't necessarily have to physically write anything. You just logically tag those assets. Once you do that, you realize that patterns appear. Because if something is connecting to something else, and you know that that is connecting, then you also know that if something bad happens here, you can identify quickly what that is. Because you've tagged it, you've labeled it, you've logically grouped that asset. The next thing you want to be able to do there is you want to be able to go ahead and put those into logical groupings so that you can contain that. So now all these assets that were disparate across different locations, we can put them into IT assets, medical assets, defense assets, legal assets, finance assets, so that if something happens in the IT side, we can block it from spreading to the finance side. So it doesn't matter where that asset is located. It doesn't matter if it's in the same location, across different locations. Using those logical groupings, you can visualize what's going on in terms of the connectivity and then put assets in place to make sure, policies in place to make sure that that actually stops that. So this is an example of what that looks like in real life. So you can actually have those assets and you can see those assets across cloud, across on-site, across different locations, and you can visualize the communication that is going on between them. So the green lines are traffic that we know is good, so we are allowing. Anything that is red is something that is bad that we are blocking, and anything that is amber is something that's a warning that we need to pay attention to. So once we've categorized this, and this is automated, right? So you don't have to have a human actually sitting there doing each one. And this is where, again, good AI can be used to counter that bad AI. So you're visualizing what's going on, you're seeing what's actually happening, and you can then actually understand the communication, because each line represents unique communication that's going back and forth between those assets. And once you have that intelligence, once you have that information, it makes it easier for you to determine if the communication is good or the communication is bad, and then act accordingly. So this is the concept of zero trust, using zero trust, least privilege for your devices, but also for your data, as well as for your people as well. And all of this comes to the concept of what we call segmentation, right? Because as Forrester have said, organizations are finally getting serious about zero trust, because now we realize we are not able to prevent everything. Something will always get in. And now, as I said before, with AI, this makes it even easier, especially for the bad guys. So we now need to think about containment more and more. How do we contain something from spreading, as opposed to how do we try and prevent everything 100%, right? And this is the concept of segmentation, putting things into logical groups so that you can understand the risks of one group to the other and contain those risks and apply different least privilege access to those different groups. So even though those things are in the same place or in different locations, you can still control them by understanding, first of all, what they are, what they do, and how they impact your organization or your business should something go wrong. So thank you very much. I hope you found this useful. And I'm with Illumio. We are just across the stand at CO2. If you have any questions, please feel free and walk across, and I'll be more than happy to talk to you about that. So thank you.